EDX Decision 1, Critical Path Analysis 1, Activity Networks, Analysing an Activity Network. We can find out several things by analysing an activity network, and we'll start with some of the basic methods. We use what's called a forward pass to find the earliest event time for each event and the minimum completion time for the project. We use a backward pass to find the latest event time for each event. We will use these in the next session to look at finding critical activities and critical paths. So in this example, here's our activity on ARC network, and the first thing we do is draw a double box at each of the nodes. So in the forward pass, we insert the number in the left hand side of the box, and this is the earliest time at which an event can occur after completing all the preceding activities. Step 2, we begin at time 0, then work forward through the network, working out the earliest start times at each event. So we go to our first event and we put the earliest we can start is obviously 0. So we started the stopwatch running on this particular project. Then we look at the second event. So this event here is the completion of B, and the earliest time that we can complete B is 0 plus 4, which is 4. Then we look at the third node. So this is the event here where we've completed A, and because of the dummy we've completed B, and the earliest time that we can complete A and B is not 4 but 6. We need enough time to complete the A. So this is the event, A's completed and B's completed, and that will happen in 6 units. Then we look at the fourth event. So this is the event when we have completed D, and we can complete D, the earliest we can complete D is the 6 when it started plus the duration 10 is 16. Then we look at event 5. Event 5 is the completion of E, but also because of the dummy we need to have completed D. So the earliest that event 5 can happen, it's either the beginning of E, which is 4 plus its duration 13, so I'll just write that underneath so we can remember it. So it's either 17, or in order to have completed D we can bring 16 down this dummy, which will give me a completion, an earliest event time of 16. So the earliest time I can use here to complete D and complete E is the bigger of the two options, which is 17. We'll need 17 units of time in order to complete E and complete D as early as possible. Then the last earliest event time is this one for event 6. So at event 6 we need to complete F, and we need to complete G, and we need to complete C. So let's just list them in order. So in order to complete F as early as possible, it could start at 16, its duration is 4, so we could have that finished in 20. In order to finish G as early as possible, it could start at 17, its duration is 2, so we could have it finished in 19. And in order to complete C, we mustn't forget C at the bottom here, it started at 0, its duration is 15, so we could have it finished at 15. So the earliest time I can put here in order to complete F and G and C isn't the 15 or the 19. The earliest time I can put in here to complete them all is 20. I need 20 units of time in order to make sure that F can be completed. So now we can see the minimum completion time for this project is 20 units. It cannot possibly be completed in less than 20 units of time. It now follows to find the latest time at which an event can occur in order to complete all the following activities within the available time. And this is called a backward pass. So I know I can complete this project in 20 units of time. So now we have to go backwards through the project. And I do the nodes in order 7, 5, 4, 3, 2, 1, 0. So now I go back to node 5. And what I'm asking myself now is, what's the latest time for this event in order to complete G in time? The latest I can start G is 20, take away 2. The latest I can start G, therefore, is 18. This event here at node 4 is the latest time that I can start F and G. I need the time in order to start F, and because of the dummy I need to start G. So it's either 20 take away 4, which is 16, I'll just write that down, or the latest time I can start G straight along with this dummy is 18. So the latest time I can put in here in order to complete F and G within the 20 units of time, the latest time I can put in is 16, not 18. If I put 18 in, I won't have enough time to do F. Then we go back to this node 3 and this event. So this event here is the event D has started. The latest time that D can start is 16 is the latest it can finish. Take away its duration of 10 is 6. So now we're looking at this event here at node 2. So this is the event, the latest time we can switch over to start doing E and, because of the dummy, D. So the latest I could start E would be 18, its latest finish time, take away its duration 13, so that would give me 5. The latest I can start D is 6 because of the dummy. So the latest time I can put in here in order to start D and E successfully is the smaller value 5. If I put 6 in here, I will not have enough time to complete E within the 18 units of time. And just checking the start node, so this node at the beginning, don't just put 0 in out of habit, do check it. This is the event that I have enough time to do A, B and C. So the latest I could start A is 6, take away its duration 6, which is 0. The latest I could start B is it could finish at 5, take away its duration, which is 1. And the latest I could start C is 20, take away 15 is 5. So the latest I can start the project in order to do A and B and C is 0. I go for the smaller option. If I put 5 in here, I will not have anywhere near enough time to complete A within the 6 units or B within the 5 units. So you'll go for the smaller option, the 0, and it should match the latest start time. So there's the backward pass. So now the earliest start time and the latest finish time for each activity can be read from the network once both passes are completed. So for example, if we look at D, the earliest I can start D is 6 and the latest it can finish is 16. Its duration is 10. 6 add 10 is 16, so we say that D would be critical. There's no flexibility in D. It must start at 6, it must finish at 16. However, if you have a quick look at activity E, the earliest it can start is 4, the latest it has to finish is 18, and its duration is 13. So the difference between 4 and 18 is 14 units of time. E only lasts for 13 units of time, so we say it has 1 unit of float. In the next session, we'll be finding critical activities and critical paths.